So, good afternoon, everybody. I will continue on our lecture about age and sex composition. Hello? Can you hear me? Someone tried to say something? If you can mute yourself. And just as I said right before we started the class, whenever I start showing these slides, I cannot see the chat. And so if you want to say something, just please unmute yourself and ask a question. Okay, thank you. So I will continue on chapter 10, related to age and sex composition. We talked before about age-sex structure using the pyramids. And I showed you also the Excel file that's available in our course website, that you can create your own pyramids. You can change colors and everything. You just need the raw data. What is the raw data for the age-sex structure of populations? Just the number of people by sex and by age group, usually 5-year age group. And then you can construct this age pyramids like this one here, or these other ones that I showed you. So you pretty much just need the number of people by sex for women and men, and for each one of these age groups, for a specific year, a specific country. It can be a state, it can be a county as well as this graph here. And you can just use the Excel file that I showed last week, and you can create your own age pyramids age-sex pyramids if you have data for a specific place. And now I'm going to talk about age dependency. So a measure that's widely used by demographers to try to understand the age structure of a population is the total dependency ratio. I think someone is not muted at home. I think Ethan, maybe. Emily. I'm sorry for calling your names, but if you say something, we can hear here in the classroom. But if you do want to ask a question, just unmute yourself and ask. But Ethan and Emily are unmuted now.
My bad.
Thank you, man. Cool. So a popular measure to try to understand the age structure of a
I didn't know my audio was on.
Sorry?
I didn't know my audio was on.
That's okay, man. That's cool. All cool. Emily, if you say something there, we're going to hear you because you're not muted. Technological problems. So age structure of a population, popular measure, it's the total dependency ratio, TDR. Here, what we are trying to do is to compare the size of the child population and the elderly population in comparison with the working age population. So the standard age groups for these three subgroups are 0 to 14 for children, 65 plus for the elderly population, and working age population, those between 15 and 64. So it's really simple. You just get the number of children in a population in a specific year, the number of elderly people, add both of them, divide by the number of working age people, who are those between 15 and 64. Usually, the dependency ratios, they are expressed in percentage terms, so you just multiply it by 100. Why is it called a ratio and not a rate? What's the specificity of a rate? In the rate, people who are counted in the denominator of a formula have the risk or have a chance of experiencing the event that's being measured in the numerator, right? So when we talk about migration rate, we get the population of a specific area, a number of people that left that area in the numerator. So those people who live there have a chance to get in out. Women in the denominator, how many children they have. Women have a chance to be counted as the number of children that they have in the numerator. Mortality, the denominator, population of a country in a specific year. Numerator, number of people who died in that specific year. And rate, we also consider time of exposure. What you pretty much give a weight to people if they lived through the whole time interval, they will count as one person year, if you're talking about years. And if they lived less, they will count it less, as we talked before. But the denominator of a formula for a rate, the easy way to calculate it, to think about it, is the population in the middle of the period in a specific population. So the population, let's say, if I want to know the denominator of a formula for migration in College Station, I have to get the population in College Station in July. That's the denominator, and then I'm going to count how many people have the chance of going to the numerator. The ratio, I'm separating my population in different groups, in different subcategories. In a specific year, in a specific population, I can either be in this group, or this group. So if I'm between 15 and 64, I'm going to be in the denominator. And I don't have a chance to be counted in the numerator. I'm just comparing the size of two groups. The first group is the one that I'm combining children and older people. The second group, working age people. And then I divide one by the other. So that's why it's called a ratio, because people being counted in the denominator do not have a chance to enter the numerator in that specific year, in that specific population. How do you interpret this ratio, specifically the total dependency ratio? I gave here general information about ratio that's comparison of two subgroups. For this specific ratio, how do you interpret it? If the ratio starts to increase, we have more people that each one of the workers have to support. So if the ratio starts to increase in size, it means that the number of children and older people are increasing in relation to the number of workers. So I will have more dependence on that specific society. So higher the ratio, higher the dependency ratio. Dependency ratio because children and older people depend on the work of people between 15 and 64 years of age. If the ratio decreases, you have a lower dependency ratio. It means that you have proportionally fewer children and fewer older people in relation to people between 15 and 64. Children and older people are usually called consumers, and the people between 15 and 64 are called the producers, right? And the consumers depend on the producers. And higher the number of consumers, children and older people in relation to people between 15 and 64, higher the dependency ratio. And so that's how we understand this formula. We can also split the total dependency ratio in two separated ratios. In one of them, I can use in the numerator only the number of children in that population and divide it by the people between 15 and 64. And that ratio is called the youth dependency ratio. In that case, I'm just looking specifically at the size of the youth population, those between 0 and 14, in relation to people in working ages. Another sub-ratio there is that I consider in the numerator only the elderly population, those with at least 65 years of age, divided by people between 15 and 64. That ratio is called the old age dependency ratio, also known as the aged dependency ratio. So I can showing the same graph, the total dependency ratio, children and older people divided by working people. I can show only children divided by working people, and I can show only elderly people divided by working people. Oh, but I know that in a lot of developing countries, we have people below 15 years of age working. And also we have, even in developed societies, people who are older than 64 working as well. But that's the standard that demographers use to calculate dependency ratios. The total dependency ratio, the youth dependency ratio, and the old age dependency ratio. Sometimes you can see some variations. Here, the working age population you can see from 15 to 60 or 15 to 69. So it depends a little bit, okay? But usually it's 15 to 64. And, And this one is one example that we are calculating the youth dependency ratio, the old age dependency ratio, and the total dependency ratio, one for each one of these countries in 2014. So we have, for example, one thing that I missed here, like this last sentence here, the youth dependency ratio added to the old age dependency ratio equals the total dependency ratio. And you see this in this table. So the youth dependency ratio in Macau, the old age dependency ratio, and the total dependency ratio. South Korea, China, and all these other countries. So for example, here in Niger, Chad, Uganda, Gambia, the youth, Nigeria as well, the youth dependency ratio are really high, right? So we are saying that we have a lot of children in those places in comparison to people in working ages. In Niger, for example, we have actually more children between 0 and 14 compared to people between 15 to 64. For every 100 people between 15 and 64, we have 106 children, which is pretty much saying that these countries have a really high fertility rate. So a lot of children are still being born in those countries, even in these more recent years. So you have more children proportionally in comparison to working age population compared to these other countries. In these other countries, what you see, and because these countries here have still high fertility and they also experience high mortality, people don't live to older ages still. The proportion of people that reach at least 65 years of age is still small. So that's why the old age dependency ratio, it's much smaller in these countries compared to the others. In Japan, for example, and also in Italy, you see the opposite trend. Fertility rates in Japan and Italy is so low that proportionally the number of children for the working age population is really low. For every 100 people between 15 and 64 years of age, in Japan you had only a little more than 21 children, those between 0 and 14 in 2014. At the same time, Japan, people have like really high life expectancy at birth, so mortality levels are really low. A lot of people reach at least 65 years of age. Then you have really high old age dependency ratios compared to other countries. Just cough. Sorry. And a summary of everything is the total dependency ratio. That it's pretty much, I'm adding the youth dependency ratio with the old dependency ratio. But look here, like when I analyze these results, a really simple table with one youth, one old, and one total dependency ratio for each one of these countries in one single year. They give me a lot of information because the youth dependency ratio gives me hints about fertility rates. The old age dependency ratio gives me hints about mortality rates or life expectancy at birth. And this one is a summary of everything. How many people in total are consumers, young and older people, compared to people in the working ages, the producers, okay? In this graph, we have only 2 countries, but we have data for several years. And here we are showing only the youth dependency ratio. So we have China in red and the US in blue. And you see that the youth dependency ratio was much higher in China. And then around the end of the 90s, beginning of the 2000s, started to be at the same level as in the US because China has been experiencing a huge fertility decline related to the one-child policy that was implemented in 1979 until 2015, but also because of economic development, it made people wanting to have less children. So there are different researchers emphasizing these 2 factors that made fertility decline a lot in China. The one-child policy, but also economic development. So it's harder for people to have a lot of children. They decide to have fewer children, and the youth dependency ratio declines in China because of that. In the US also declined because we had also a decline in fertility in the 70s, and it has been kind of stable over time, right? So when we are talking about these youth dependency ratios, we are emphasizing fertility rates, right? The effect of fertility rates on these countries. The same countries, the same years, but here now talking about the old age dependency ratios or the aged dependency ratios. And we see that they have been increasing both in the US and in China. And projected information to these projections for China in the next decades show that the proportion of older people, those with at least 65 years of age, you keep increasing in a really steep manner in comparison to people in working ages, even more than in the US. We'll surpass the US around around 2035, right? So in this case, why this is happening, you have fertility decline, and then in the next generations, those children between 0 and 14 will enter working ages between 15 and 64. So the group between 15 and 64 also declines in these next decades because fertility declined in previous decades. And people in those countries are living longer. You have higher life expectancy at birth. So the number of older people is higher in comparison to people between 15 and 64. So in the old age dependency ratio, you kind of like see both effects here. The decline in fertility in previous decades decreased the number of children, but as we look at what's going to happen in the future decades, in the future years, these children start to get older. They will enter the group of 15-64, which will be smaller. And then more people reached older ages. And these people that reached older ages, they were born in a time when fertility was higher. So proportionally, the number of older people is going to be higher in comparison to working age people in these future decades compared to previous decades. Okay? This is an example only about Brazil. So here I'm showing all the ratios here. The old age dependency ratio in purple, the child dependency ratio in orange, and the total dependency ratio in black. And for several years as well, and I collected this information from the United Nations. Okay? And what do we see? Fertility in Brazil started to decline a lot around the end of the 60s and a lot in the 70s and 80s. So it made the population have fewer children between 0 and 14. So the child dependency rate starts to decline since like mid 60s and still declining, but you reach a point in which like the total fertility rate in the country, it is below 2 children per woman, but it's not gonna keep declining because people are still gonna have children. So keeps declining here. We expect these next decades, but not so steep as it was in previous years. And we experience health developments, better health to people, mortality declines, people live longer. We have a higher proportion of people living to at least 65 years of age. The old age dependency ratio starts to increase. And it increased really fast since 2010, and is expected to increase even more. So that's what we see from these two separated ratios, the youth dependency ratio and the old age dependency ratio. And when you combine both of them into the total dependency ratio, what you see is that in previous decades, the shape of this curve here was really driven by the shape, by the pattern of the child dependency ratio. Because these values here were really high compared to the ones of the old age dependency ratio. And then and then you get this moment here that the total dependency ratio kind of like stays flat because the child dependency ratio is decreasing, but the old age dependency ratio is increasing. So one kind of neutralize the other one. And then in the future decades, we expect that the total dependency ratio will increase exactly because we're going to have more people living to at least 65 years of age. And demographers, why is this important here? Because if we look at this data and we look ahead as policymakers, we try to say, oh, I'm back here in the 90s or in the early 2000s. And as a policymaker, I see these projections from demographers, and I see that between 2005 and 2025, we're going to have the lowest levels of dependency ratios in Brazil. We are in the middle of that in Brazil. What does it mean? That proportionally, we have fewer consumers in comparison to producers. We have fewer children and older people compared to people in working ages. So if I looked ahead in that kind of data and I say, okay, so I still have a lot of children here, but the child dependency ratio is declining. But if I invest in education into these children, when they get into working age ages, in the working age group, they will have higher educational attainment, and that will increase productivity in the country. So I'm thinking how demography can help economic production into a country. And if I invest early on in these children, in their education, when they reach working ages, they will have college degree and they will actually produce in a much more efficient way goods for the society, because we're not going to be working in agriculture or in occupations that don't demand much, doesn't demand high skills. And this was experienced by countries in Southeast Asia. But the difference between Southeast Asia and some countries in Latin America is that when the Southeast Asian countries reach these low levels of dependency ratio, before you got the effect of the old age dependency ratios increasing, when they reached here, they had a really high proportion of well-educated working age people in the society. And that generated an economic development at the end of the 90s in those Southeast Asian countries. And there are studies by demographers emphasizing exactly that. What's the challenge in Latin American countries such as Brazil? That education attainment is still really low. So you do have this chance of having demography influencing in a positive way economy, but a really low percentage of the population still has a college degree, for example, around 10% only. But what I'm emphasizing here, that's what demographers call a demographic dividend. We have this window of opportunity, and you also hear this term, window of opportunity, in which the dependency ratios will reach the lowest levels exactly because of fertility decline, but it's still not a really high percentage of people in older ages. So you reach this point here in which if you had invested on education, on training of the young population, they would produce more later on in life. So there are several policies. So investing on child education, increasing female labor force participation, creating policies that also make people save more money. So they save more money while they are working. And so later on in life, when the total dependency ratio starts to increase, then they will have savings to survive in older ages. But this moment here, this window of opportunity that has the dependency ratios really low levels, and in the case of Brazil, is between 2005 and 2030, that's what we call demographic dividend. If you Google it, you're gonna see a lot of articles written about demographic dividend. Another term that demographers use for demographic dividend is demographic bonus. But the most popular one is demographic dividend. Some demographers also say if you do not take advantage of this moment here, and when people are working, they don't save to have money later in life, when they reach older ages here, they will put a lot of pressure in the society in terms of Social Security because they don't have enough savings. They will rely only on government Social Security, and that can increase poverty among older people. And some demographers use this term demographic onus, but that's not a popular term that you might hear a lot. But demographic dividend and this window of opportunity is something that we hear a lot in demography. Cool. The next subtopic of this chapter, it's pretty much a discussion about methods. Whenever we ask people in a questionnaire about their age, some people might not report their age exactly how old they are at this moment. They report in an incorrect manner. So what demographers came out was with a technique to try to understand the quality of the data related to age of people. It's pretty much I go to each one of you and ask, what's your age, and I write down in my questionnaire. And demographers came up with this technique that tried to see if that reported age by individuals has a good quality or not, whether they have irregularities or inconsistencies that show us that we should not trust a lot the data that were reported by age. What happens a lot in several countries is this issue called age heaping. Age heaping happens if a population tends to report certain ages at the expense of other ages. So if I ask them, oh, what's your age? That person might be 23, 24, 22 years old, but the person just reports, oh, I'm 25. Or someone might be 17, and that person reports, oh, I'm 15. Just round it up to a number ending in 0 or 5 because it's easier to remember. They just round it up when they report it to the interviewer. And this problem with quality of data related to age heaping, in which people, they choose specific numbers that end in 0, 5, or other numbers, tends to happen more in subgroups of the population that have lower levels of education. Some people that don't know exactly their age, and that's really typical in developing countries, exactly because developing countries have a higher proportion of people with lower levels of education, right? Some examples of age hipping. In some cultures, certain numbers and digits are avoided. For example, 13 is frequently avoided in the US, in the West, because of being considered an unlucky number. In the US, in some Western countries, sometimes we have floors that are not designated as 13. I never saw that in Brazil, but I saw that for the first time when I went to New York in a building there. I saw the floors as 12 and then 12A and then 14. They jumped or they renamed 13 by 12A. So that's because of a cultural factor. So some people might be 13 years old, but if they are asked directly by the interviewer, they might report being 12 or 14 years old, right? The numeral 4 is avoided in Korean and China, since it has the same sound as the word character for death. And many hotels in China, South Korea, and other East Asian countries do not have floor designated as 4. So the same idea as the 13 in the US and Western countries, okay? So if a father is being asked about the age of the child, and the child is 4 years old, the father or the mother could report, no, that child is 3 years old or 5 years old, for example, okay? And that might create problems with the quality of the data. And how do you measure whether you have problems with data that report ages for a specific population? We can use this Whipple's method. It pretty much measures the preference for the terminal digits of 0 and 5. Usually people prefer to report ages that end in 0 and 5. It's easier. And for this specific method, for this specific index here, we collect information, single ages, people at specific ages, 23, 24, 25, and so on. So for people between 23 and 62 years of age. And how do you calculate this index? The denominator, you just add everybody, all the population that reported being 23 years old, 24, 25, until 62 years of age. You just add everybody there in the denominator. In the numerator, you add all the people that reported being exactly on ages finishing on 5 and 0. So 25, 30, 35, 40, until 60. You multiply that by 5, and then also multiply by 100. So theoretically, what are the values that we could have in a specific population? What's the range of this index of the Whipple's method that we could have? It could be any number between 0 and 500. When we would get 0 from this formula here? When we have a population that nobody reported being 25, 30, 35, 40, 45, 55, 60, when you have nobody reporting those ages, here is 0, divided by the rest of by everybody else, we get 0. What about if we get everybody between the ages of 23 and 64, everybody that was interviewed in a specific country in a specific year, they reported just ages ending in 5 or 0. So everybody's here, 25, 30, 35, 40, 45, and so on. So the number that we're going to add in the numerator is going to be the same one in the denominator, because we're going to have nobody 23, nobody 24, nobody 26, Nobody 27. So this number here, when I add all these numbers, is going to be the same thing as adding everybody else here. This number divided by this number, equal numbers, equals 1. Times 5, 5. Times 100, 500. When only digits 0 and 5 are reported. But let's say that in this society, you have people in all these ages between 23 and 62, the same number of people across all these ages, 23, 24, 25, until 62. Same number of people in all these single ages here. And then here in the top, you get only the ones with 25, 30, 35, 40, and so on. So here, when you divide this number by this, you're going to have pretty much 1/5. 1/5 multiplied by 5, 1 unit multiplied by 100, 100. So this range between 0 and 500 is the technical possibility of reaching up these numbers. And the 100 would mean exactly that you have the same number of people across all these ages. But in practice, that doesn't happen. In practice, we don't get numbers so high as 500. So looking at the real data, empirical data for several countries in several years, demographers came out, this Whipple's method subdivides the real result of data into this level here in terms of accuracy of data. So if we get a result from this formula that's less than 105, that's highly accurate. If it's lower than 105, it doesn't have to be much closer to 0, because closer to 0 would be actually people just reporting, not reporting 0 and 5. So, and it doesn't have to be really, really, really close to 100. Any number calculated below 150 is already good. Between 109.9 and 105, fairly accurate. Between 105 and 109.9, fairly accurate. 110 and 124.9, approximate, until numbers that are at least 175. So this data, if we get the Whipple's method calculated for a specific country that reaches at least 175, then we have problems with the age information. Some examples. This is data for Korea in 1995. And we have here the ages of people between 0 until 85 for single age groups. But this Whipple's method here, this index, is calculated only for people between 23 and 62, as I showed before, 23 and 62. And we reach a number actually really, really close to 100, 100.1. Really highly accurate, pretty much saying that there's no preference for 0 and 5. Another example, Pakistan, 1981. Then you see all these peaks of ages for specific numbers. So here, people report exactly 20, exactly 25, exactly 30, 40, 45, 50, 55, and really a lot of variation, and people reporting numbers around those ones that I just read, really fewer numbers, really smaller, fewer people in those specific ages. And the Whipple's method here gives us 330. It shows that this data collected for this country, Pakistan, in 1981, is really rough. It's not really reliable, right? We got there at least 175, more specifically, really high, 330. With this data, I would not use this data in single ages. A way to deal with it, instead of using more complicated methods, a simple way to deal with it is to analyze age distribution for Pakistan in 1981 using this data only by 5-year age groups. So you just group people between 20-24, 25-29, 30-34, and so on. Okay? Because then you put these people in the same age group, 5-year age groups, and you have a more smooth distribution of this data by ages. So that was age heaping. And now, talking about some demographic indicators related specifically about sex structure. So we started a chapter talking about age and sex structure, and we showed you the pyramids. And then now, just today, I focused on age structure, and I showed you problems with age data. And now I'm going to talk about sex structure by itself. And the sex ratio is the most popular index when you are trying to understand the sex composition for a specific country in a specific year. It's pretty much you divide the number of men by the number of women in a specific population in a specific year, and you multiply by 100 to have that information in percentage terms. If the sex ratio is above 100, we have more males than females. If it's below 100, we have more females than males. Right? So we just get the number of men divided by the number of women, multiplied by 100. And that's the interpretation. Above 100, more men. Below 100, more women. In general, national sex ratios tend to fall in the narrow range of about 95 to 102. And national sex ratios, so sex ratios for a full country outside the range of 90 to 105, we should view them or interpret them as being extreme. There is something in that society that it's making you have either many more women than men or many more men than women. Okay? And what we already saw in some graphs in this semester, in this class, is that some countries, because of culture of these countries, parents usually prefer to have sons. So they perform an abortion after realizing through ultrasound that they're going to have a daughter, and that increases a lot the number of boys in comparison to daughters. But on that, I'm talking about specifically about number of people being born in that specific year. In the sex structure here, for now, the sex ratio, I'm getting everybody. All men divided by all women, not taking into account their ages. And some examples, we have, this graph I showed to you before, I think in our first lecture. We have data for more developed regions in green, United States in blue, less developed regions in orange, and then China in red between 1950 and 2015. What we see is that in more developed regions, including the US, the sex ratios are below 100. What does it mean? Overall, more women than men. Why these more developed regions in the US have overall more women than men? Usually in those countries, there is no preference for sex of the child, and usually men and women have the same opportunities in the society. Still a lot of gender inequality, but men and women have similar opportunities in those countries. Oh, but if they have all equal, they should be closer to 100. But women live longer than men. And women living longer than men, in each one of these years, you're going to see more women than men in those countries, and usually more developed countries, so the sex ratio is below 100. In less developed regions, you usually have this preference for sons, So you perform abortion, sex-selective abortion, and increase the number of boys. And in those societies, you still have a lot of gender inequality. So women don't have the same opportunities as men. They don't have as a good education, good jobs, and usually they have better mortality, so higher life expectancy. In less developed countries, this advantage is not so high compared to men. So overall, you have more men than women. And that's really pronounced for China here, the red line. But what you see for more developed regions in the US is that you have more women than men, but at the same time, now the improvement in mortality for men is also catching up to the levels of women. So you start to have the sex ratio, it's not so low anymore, both for all developed regions taken as a group or the US by itself. It's getting a little closer to 100, saying that men are living a little more than before, but it's still less than women. So that's why it's still less than 100. And this preference for boys is still high in China, even for more recent years, and kind of stable overall in less developed regions. Because that's not just preference for boys, it's also related to the chances that women have in the society in terms of health, resources that they receive, and in terms of education, health, jobs, and everything, that will affect their mortality, okay? This is just South Korea, and this is just data for 1 year, 1995. And the horizontal axis here is age group. So it's different than before. And here we have again, men divided by women, multiplied by 100. In younger age groups, because of preference for boys, you have many more boys being born than girls. More than 100, like around 115 boys for every 100 girls. But because women live longer, this advantage declines as people get older until you have here already around 50 years of age. Oh, no, this one here. Yeah, 50 years of age. Around that, you have the point in which the number of men and women is similar, and then women keep living longer, men start to die faster, and the sex ratio reaches levels below 100. Okay? So in this graph here, we have several years for these 4 different groups of countries, and this one here, we have 1 year, 1 country, but several age groups. So just to show you that this simple measure of number of men divided by the number of women multiplied by 100 can give a lot of information about these countries, okay? The United Arab Emirates, you have the opposite. You actually increase the number of boys or the number of men over time. Like still more boys being born than girls, but as you start to look at older ages, you have more men than women in really, really high levels. Here on the age between 50 and 54, you have around 325 men for every 100 women. 60 to 64, around 340 men for every 100 women. Why is that? Because these countries, they rely a lot of immigration from other countries of male workers to work in the oil industry, and they usually give preference for men as immigrants to work in those countries. So exactly in these labor ages, you see more men than women. Or not, let's see, until 60 to 64, and people start to retire and maybe going back to their country or dying, you see a decline in the sex ratios, right? But this is exactly because of the country relying on the labor force of immigrants, people from other countries to go there and work in their economy, okay? So with simple graph for one country, 1 year, gives us a lot of information of how the society is organized. And just imagine in a daily life, around 45, 49 years of age, you have 3 men for every woman in the society. So it's completely different how the society is organized, right? And this is the same idea as before. This graph here, the sex ratio, we get the number of men divided by the number of women by age groups. And this is the age-sex pyramid, which is the same data as before, but instead of dividing one by the other, we show it separated graphs. And then we see many more men in these age groups between 20 and 54. Many more men here compared to women, right? The data here is from 2000, and this is data from 2015, but it shows the pattern. It's consistent over time, okay? Because that's how the society relies on these workers. Cool. And another measure for sex composition that's important, is really widely used, is the same sex ratio, but now focusing only on the number of boys and on the number of girls being born in a specific year, in a specific population. So it's pretty much number of boys born in a specific country, in a specific year, divided by the number of girls, multiplied by 100. Most societies have sex ratios at birth of around 105. What does it mean? That 105 boys are born for every 100 girls. Number of boys divided by girls multiplied by 100. Usually it's around 105. But China, Taiwan, South Korea, India, and several other Asian countries, they have been reporting really high sex ratios at birth since the 80s. And that's related to this preference for having boys. So people have a prenatal sex identification with ultrasound. And if they're born with girls, they usually perform an abortion because they want to have a boy, right? And that generates really high levels of sex ratio at birth. China and Taiwan have a Confucian patriarchal tradition where some preference is strong and pervasive. Birth planning policies, socioeconomic changes, and industrial transformations have been responsible for the rapid decline in fertility. And then ultrasound technology enables the prenatal determination of sex. This is exactly what I mentioned to you guys before. In China specifically, between 1979 and 2015, the one-child policy really put pressure on people to don't have many children, and the name said one-child policy. But still, a lot of people had more than one child. That was allowed by the government. But the levels, on average, of the total fertility rate in China dropped to around two children per woman, even though you have the name of one-child policy. But exactly because of that pressure of not letting people have a lot of children, if Chinese women were pregnant with a girl, the couple would decide to perform an abortion, mostly if that was the first child. But not just the birth control, the family planning program or birth planning policy had an effect. Also, socioeconomic changes and industrial transformations. It starts to get expensive to have more children, even in all over the world. Start urbanization, it's more expensive to have children, to sustain children, to buy food, to provide education and everything. So people also start to have fewer children. And having fewer children, but a preference for boys, then sex ratio at birth increases a lot. And that's what we see in this graph. China in red, Taiwan in blue, and the US in green. The US around the biological normal, 105 boys for every 100 girls being born in a specific year. And this is data from 1980 to 2010. And then in China, you start to see this increase a lot exactly after the implementation of the one-child policy, although even with the one-child policy, like as mentioned before, it's a misleading name because still total fertility rate was around 2 children per woman. But exactly that had an effect on people having preference for boys. And then the sex ratio at birth increases a lot in China, reaching around 120 boys born in 2010 to every 100 girls. But also in Taiwan, you have higher ratios compared to what would be the biological norm around 105. Okay? And then finally, the last topic here in this chapter about population aging. And population aging is related to age structure of a population. I mentioned before with the dependency ratios. Fertility decline, it declines. The youth dependency ratio starts to decline over time. Fewer children compared to working age people. People start to live longer, improvements in mortality. So you start to have higher proportion of older people compared to working age population. And this process in which you have declining fertility, declining mortality, in other words, increasing in life expectancy, people reaching older ages in higher percentages, this process is known as population aging. Large numbers of elderly persons are not a problem if there are a large number of producers. It is a problem when the ratio of elderly to producers become high, generating socioeconomic problems. I told you, who are those producers? Producers are the people between 15 and 64 years of age, people in working ages. Elderly people are consumers. Children are consumers, but with declining fertility, we have fewer children. And fewer children, people getting older, and you start to have large amounts of people with at least 65 years of age. Your society will have to have a lot of resources, Social Security, a lot of resources to maintain a minimum quality of life to the older population. And if this older population, when they were in working ages, they were not able to save for their retirement, if you have a private retirement system in the country, they will face a lot of issues later on in their lives. Or if they live in a country that's all based on public Social Security and it's not a good quality, it doesn't provide minimum standard of life for that population, they will also face difficulties. And these two next bullets here is pretty much summarizing the results of the table in the next slide that I got from the textbook. In 2020, projections indicate that more than 1 billion, we're going to have more than 1 billion older people in the world. So right now, we have around 1 billion people with at least 60 years of age. And more than 20% of these people with at least 60 years of age are in China. And around 7.4% in the US. If you look at the oldest old age group, in this case here, people with at least 80 years of age, we have right now in the world almost 150 million people with at least 80 years of age. And 20% of them are in China. And around 9% of them are in the US. So China really needs policies to sustain this increasing old population. And because they have so much fertility decline in the past decades, now you don't have as many workers between the ages of 15 and 64 as before, proportionally speaking, and that is more difficult for the country to sustain itself. That's why now China has been actually creating some policies to incentivize people to have more children. Okay? Where did I get these numbers from? For these 60 plus people, this table here, we have the years from 2010 to 2050 for the world, for China, for the US, the total population, people with at least 60 years of age, people with at least 80 years of age. And in my example here, I got data from 2020. So I just got in China, this number here, 245 million, divided by 1.04 billion in the world, we get 23.4%. Okay? And 28 million divided by 148 million, you have the 19%. And I did the same thing for the US comparing to the world. But just to show, out of 1 billion people in the world right now with at least 60 years of age, 245 million of them are in China, almost 25%. One on every 4 people with at least 60 years of age are in China right now. They are Chinese, they live in China, right? So that simple table for the world, for China, the US, for these specific age groups and year gives us a lot of information. We can play a lot with this data here. And this graph here is just to show why demography, why understanding population aging relates to other areas in our society. The Economist in 2017 organized this data for several countries, getting the population age 65 years and over as a percentage of the total population in the horizontal axis, and then in the vertical axis, the government spending on pension benefits. Pension benefits, exactly related to giving support to older people. And that's the government spending on pension benefits as a percentage of GDP, the gross domestic product, as a percentage of everything that's produced in a specific country. And for example, here, got an easy number, let's say around 13% of the population in South Korea in 2017 was at least 65 years old. In Japan, around 27% of the Japanese population in 2017 was at least 65 years old. The more people, the higher the proportion of people in old ages, you expect the government to spend more money towards them in policies, right? So as you have a higher proportion of people in older age groups, you expect the government to spend more on pension benefits towards that population. So you have this positive correlation. But you have some outliers there. Which one is a really clear outlier? Is Brazil. In 2017, around only 5% of the population was at least 65 years old. Fertility is declining in Brazil, mortality is improving, so people are living longer, but still, in 2017, the proportion of only around 5% of people were at least 65 years old. But the way that the government is organized in terms of pension benefits, 12% of all GDP in Brazil was already being allocated to pension benefits. That's why there is so much debate in Brazil, and several other countries like Turkey, the same thing. 5% and already almost 8% of the percentage of the GDP being spent for pension benefits. So there is a lot of debate in relation to pension reform. But then it becomes ideological. So the data is showing that we have an issue. But then it can become ideological. The sense that, oh, do we cut the benefits, the spending towards most of the population that receives lower pension benefits, or from those few privileged people that have really high pension benefits from government jobs, such as judges, prosecutors, and so on. And those people have more political power, right? So if you really want to deal with pension, this pension pressure, because of the population now getting older in Brazil, you have to cut not from those that have few pension benefits, which is the large amount of the population, but you have to go towards the few that have really high pension benefits because of the way that the country is organized. These government jobs that pay really high levels of earnings to judges, to prosecutors, and so on, to the military, and then they are the ones putting the pressure, although they are a smaller proportion of the population. So that can become really controversial when you try to change policies to deal with this issue. And the economists collect the data, but this political scientist from Brazil, Jairo Nicolau, he organized this figure. And I follow him on Twitter. That's where I got it from. And there are like other countries that the economists collect the data, but I like the way that he organized this one here. It's easy to see the names and everything else. But the economists also collected that for other countries as well. Okay? So then we finish chapter 10, related to age and sex structure. Just to emphasize, we have a lot of this Excel file. There is an Excel file in our course website called Excel Age Sex Structure that has a lot of graphs. And the one on the bar chart is the one that if you enter information by age group, by sex, male and female for a specific year, this is just pretty much the counts. Just typing here. This information here calculates the proportion or the percentage of women in each one of these age groups and the men in each one of these age groups, adding up to 100 in total. So this one here is just getting information for this woman divided by these two, men divided by the total. You do it for everybody. In order to work in Excel, you have to put one as negative, so you multiply here by minus. And so it's multiply here by minus. For men, it's just positive. And then you can do the graph like this. Male on the left, female on the right. Although female is negative here, I inverted the graph in order to show women on the right, because that's the standard. And I just put women negative here because it's a glitch in Excel. Because the way that it works here now, we have both in the graph and the legend, women. So it's easy to understand. But if you type any data here for any country, state, county, city, for a specific year, for these age groups, by sex, for men and women, it automatically generates the age sex structure. And that's for the first column, 1970, 1980, 91, and 2000. Those were the census years in Brazil, right? Those years here. And I also have dependency ratio. This is another way to show dependency ratio. The light blue is the youth dependency ratio. The dark blue is the old age dependency ratio. And the height of everything is the total dependency ratio, right? So you see that the child dependency ratio is declining over time. The dark blue is becoming thicker over time, so more older people compared to workers. And here, that's the window of opportunity that we saw in previous graph. As we are around 2005 and 2025, you have the lowest levels of total dependency ratio. And that you can collect the data and do it by yourself and generate these simple graphs in Excel that are really straightforward. And we have only 5 minutes, but we just continue here on the next chapter about world population change over time. These next two chapters is about trends in population in the world. And then after we finish this one here, we're going to talk about the US. And in this specific one, I'm going to focus on the first two topics here. Some 5 contemporary aspects of importance in demography in the world. What are major changes in demography that we are seeing in the world? And I'm going to talk about this demographic transition, this overall trends of declining mortality and declining fertility over time. That's kind of like similar across society. Some societies, they pass through demographic transition in early decades and earlier centuries than others. But in this discussion about the demographic transition, we're going to go deeper into it on the chapter about theories of demography, which is chapter 2. But here on this chapter, I'm going to just show you a big picture of what demographic transition is, show you some examples, but we're going to go deeper into it again on the chapter about theories of demography. And all this material here on global population trends is extra information that I'm not going to cover in the course, but the slides are there, and it's from another textbook. So at the end here of this chapter, so Wix is the source of data that I got for that third bullet point. But the first two, they come more from our textbook by Poston and Bouvier. Okay? The quiz today, that's going to be open at 4:30 p.m. today until noon tomorrow, is going to be only about the previous chapter, only about age-sex structure. It's not going to cover this chapter here that I'm starting now. So there are 5 major changes that are going on in the world that are of importance in demography. One is that the human society increased a lot over these last centuries. So that's the greatest demographic change in human history. You pretty much have a huge increase in population size in the world. You also have huge declines in mortality, which means that people are living longer, right, in more recent years compared to previous years. You also have declines in fertility. And whenever you're talking about declines in fertility, you hear this term, fertility reached below replacement level. What does it mean, fertility below replacement level? It means that women on average are having less than 2 children. Why exactly 2 children? Because they're having less children to replace themselves and the partner, right? But usually the replacement level we consider as being 2.1 children per woman. Why 0.1? Because you still have more boys being born than girls, so you need some extra girls to afterwards become pregnant and produce more babies. And also because some of these children are not going to reach older ages. So the 2.1 is the total fertility rate, TFR, of 2.1 children per woman is considered the world number for fertility below replacement level. If you reach a level of less than 2.1 children per woman in a country, that country reached really low levels of fertility below the replacement level. You still have countries nowadays that have really unbalanced sex ratios at birth. What does it mean? Many more boys than girls. Sex ratios at birth much higher than 105, as we saw in the previous chapter for China and Taiwan. So you still have all this imbalanced sex ratios at birth. And related to the last topic that I just talked in the previous chapter, you have, because people are living longer, fewer children, you're going to have a higher percentage of the population in older ages. So it's 4:30 right now. I will continue on this on Thursday. The quiz 3, it's open now on Canvas. And yeah, that's it. Thank you very much. And I see you guys on Thursday.